Good afternoon, everyone. Thank you for giving this opportunity to talk here. My presentation or my topic is more about sustainability in water in the industry. Before I start my presentation, just want to put it, look, I'm not a chemical expert, but where we bring expertise on handling wastewaters, how we can make your industries or your manufacturing more sustainable, how we can recycle more water, and some of the case studies, So this presentation would be, would have a couple of components, The first component would be more about what we are as a Veolia of the organization. Second component, we talk about two solutions to the industries. And third topic, we will more talk about, some of the case studies, So, so basically, Veolia is an environment company based out in France. I would say it's the oldest company for the environment business. It's around 160-year-old company. And, it's a global company with a mantra which we always take, that we always win when our customers win. It's very simple, Whatever we do in our business, in the region, globally, anywhere, About us, we as a Veolia, we are basically a 220,000 employees company, 28.5 billion euros as a revenue, 5.2 billion meter cube of wastewater handled, 350,000 metric tons of plastics being recycled. Inside the Veolia, we have the company called Veolia Water Technologies and Solutions. Veolia Water Technologies and Solutions talk about more technology perspective. We are 10,000 employees, 50,000 industrial and municipal customers who have been served, more than 10,000 combined technologies, and around 11.4 million meter cube of water treated every day, as a part of solution being delivered. Some of the culture which we always share, three things we always say in whatever we deliver as a solution, It's quality, safety, and compliance, right? So quality every time when we deliver a solution, safety every time whenever we execute project, we deliver a chemistries or whatever we do, And the compliance point of view, whichever country we are working, whichever applications we are working, are we compliant to those laws? On the sustainability part, these are some of the applications which we deliver solutions on. It starts from industrial water treatment. Look, today, we all agree that we are in a country which is a water-stressed country, right? No one can deny this, Before me, Mr. Naidu has already talked a lot about the challenges which we are facing on water availability. People are not having drinking water, 40% people are not getting right? So industrial water treatment is always looked to be very conventional, very simple, right? A clarifier, multigrade filter, carbon filter, ROs, right? Here, what perspective we want to bring in is about the recoveries, right? We can deliver reverse osmosis plant with a recovery as high as 98%, And the plants are being delivered in the country, where you can recover water at 98%, 99% without having those multi-effect evaporators, right? Process enhancement. We can get into your chemistries, right? If you're having a challenge of any scaling, or a challenge of corrosion, we can bring in our chemistry. We do a lot in refineries, and some of the chemistries, the bioagric chemistries and all, right? Wastewater treatment, the most complex structure, in chemical industry, if you always say the challenges are high CODs, high ammonia, you strip it out, CODs is not breakable, ROs can concentrate, MEs can evaporate, but you again get it in condensate. How to solve that things, right? So we can help you. We have a lab full-fledged in India at Bangalore. We can collect the samples. I'm not coming on the ground saying that we have an expertise of everything, right? But we can jointly solve a problem because we have done multiple times globally right now, Zero liquid discharge, again, look, this is a sustainability forum, right? If I recover all the water, we are left with the water which is very coarse, right? What to do with that water? So you need a reliable and a very robust solution on a zero liquid discharge. That's what we bring on the table, and we'll talk about a little bit more on that during the presentation. Ultra pure water, again, not too much related here, but it is more for PV, electronics, and pharmaceutical. If you need a very high purity water, we are the largest globally who do high purity water. Tough to treat water, the water which we don't know how to treat, we are ready to treat it. We have so many technologies, labs, solutions, and we can do those combinations. We do a lot on AOPs, we do ozonation, biologically breaking those, thermal breaking it up, right? We have done, I can share a small case study here. We've done a project for Jindal. The problem statement was there's a coke oven water comes out. When you have an ore which is coming out of iron ore and you make a balls. And when the balls are made, you use water. But when water comes out of that, it has everything. You have cadmium, you have unbreakable CODs, you have hazardous substances, and it's not easy to break it up, right? A 6-month study is being done, piloting being done. That was the world's first project being delivered, and today we have multiple in India and globally. Desalination, nothing too much talk about here. It's a very simple reverse osmosis based treating seawater. Waste to energy, again very interesting, okay? We are the world's largest power producer from waste, okay? We make 6 terawatt of energy every day, okay, from the biogas. Water treatment chemistries, we are into chemistries as well, okay, where we help, on the wastewater or a reverse osmosis, cooling towers, processes to use those chemistries. And these chemistries are manufactured in India at Bangalore. Monitoring and automation, you can't have these technologies unless you get into some automations, digitalization and all, right? And we are again there. Membrane technologies, you want to purify your acids, you want to purify some of your streams. We have done multiple ways. We can try membranes, okay? And my experts are here at the stall. We have a stall at C51 where we can talk about purification of any stream if you want. Thermal separation tech, again, if there is a pure salt manufacturing. I've already spoken about zero liquid discharge, but if there is a pure salt manufacturing, we can talk together on that as well. Huge experience of last 75 years we are bringing on the table, okay? Disinfection technologies, again, we are into ozone. Again, we are the world's largest by name Ozonia brand. You talk to any pharma companies, they know Ozonia very well for last 50 years. Those Ozonia ozonators are being used. For chemical industries, we are using those ozonators for AOP or probably hydrogen peroxide or a combination, multiple things coming together, okay? Anaerobic digestion, I know the topic is not very relevant here because these CODs are not very degradable, but we are here to serve that as well. Instrumentation and the mobile and outsourced water. We are open to even deliver projects on built on operate. We are doing for Tata Chemicals in India. We are doing for some of the developers in Mumbai. So we do those things as well to deliver more confidence, okay? Now, chemical process industry, right? In a sheet, I can't talk everything about chemical process industry. But what we do understand is it's more about butadiene, ammonia, fertilizer producers, and other chemical manufacturing, right? We bring years of experience over there, okay? We work in their processes globally, in Europe, US, even in China, and a lot of other countries, right? We understand the run length is a bigger challenge, right? We can boost those run lengths, okay? We do understand, the corrosions, the scalings, right? We can help you to avoid those in your own systems and reactors. Similarly, on the agricultural chemical industry, we can help to, again, very similar. We can help have a better, longer runs. We can help lower the foulings component and all, right? Now, coming on the part of solutions, right? As I said, it is divided into 2 components, okay? One is on the chemistry side. Now, as a chemistry, we can come to your manufacturing plant where we can take the entire water treatment, where we talk about raw water, wastewater, we talk about cooling towers, boilers, which is more about utilities. One area. Second area is we can get into your processes along with you, okay, where we can help to, I can't comment on the problem statement, but it could be more recoveries of your own ingredients, or it could be purity, or it could be any scaling or corrosion factor coming in, okay? So like, it is being written as dust control, fuel treatment, process treatments, corrosion control, phase separations, fouling control, finished products, hydrogen sulfide, scavengers. On the local part of the country, we started in 2001 in India. Okay, we are 1,500 employees, 3 manufacturing plants. We make these chemistries in India. We have come up year over year, multiple. This business used to be known as GE Water and Process Technologies. It was General Electric company, which lately being sold off to Veolia, and now it is part of Veolia business. And we make these chemicals, membranes in India at Bangalore, and it export to multiple countries as well. Now, second topic which I want to touch upon is it's a little bad topic. No one would like to talk about it. It's a zero liquid discharge. We know it's a liability. It's not giving an earning to a business. It's always, zero liquid discharge has always been known as a liability, right? But today, when the market is growing, right? When the exports are growing, when the country is coming up that, or when the globe is now talking about China plus one country as a strategy, right? We would not like to be left behind, okay? So what is that we should do to be more reliable, to be more robust, right? So we are only coming up as a partner saying that, look guys, we can deliver a solution which can be more robust and reliable based on our experience we are coming in, right? So here my topic is about zero liquid discharge, okay? And I'm sure if you're from the industry, everyone would have heard about it, right? Everyone would agree and say that, the system what we have right now have challenges, okay? You operate it for 20 hours, you clean it for another 4 hours, right? That is not the way it is operated. I can tell you my crystallizers, when they operate, we clean them once in a year, okay? We don't clean them every day, okay? When the replacement happens, it happens probably 15 years or 20 years down the line, not every year or every 2 years, okay? Second problem statement in zero liquid discharge, which is coming in the country right now, is gas versus steam, okay? Now today another problem statement is coming that government, because of the carbon dioxide capturing, because of the COP, the country is shifting for generating steam from coal to gas, okay? Now when you shift from coal to gas, well, I'm sure you all are aware about it, your cost of generating steam goes multifold. It can go 3x or 4x even, right? The zero liquid discharge is also a guzzler of steam. We are bringing a solution over here where you don't need steam at all. It's a pure power-driven system, and we don't get into that steam manufacturing. So your operating expense become very low, okay? So now, again coming back on zero liquid discharge, two things. How you can reduce your operating expense, why we are worried. I think as an industry is not worried about putting an investment. Industry is more worried about what to do for that operating expense, because that kills every day, right? Two solutions. One, can we have a high recovery systems? Can I reduce the ZLD size by 5 times, 4 times, okay? Can I have a zero liquid discharge on a power driven where my operating expense become very small, okay? And these are the two answers we are going to talk about here, okay? So zero liquid discharge is more about availability. We are a red category country. I think no one can shy away with that, right? And we want to manufacture more. We want to export more, right? What to do? We have to recycle this water again and again, okay? Quality, our water is polluted. Either I'm coming from Delhi or you're in Mumbai or you're in any other state, our water is polluted, okay? And regulatories are getting stronger. Productivity is another area where I'm sure you're aware that Europe, the new law which has come up, they've started talking about how much water are you consuming per kilogram of product you're manufacturing, right? This is one of the criteria they've started putting, okay? Even US has now started thinking around that line, right? So tomorrow they may ask us, if you're making a textile or if you're making a chemical which you want to export, how much water are you going to consume per kilogram or per ton, right? So this is where it is important to have these recycling and recovery systems. Now, achieving a zero liquid discharge, what do? You put up a biological process or a chemical physio process, you put up multiple reverse osmosis and a zero liquid discharge. That's a scheme you follow. Based on the recoveries, you start with a recovery of RO, you design at 80%, a month, 6 months down the line, people will complain, it's not operating at 80%, it's operating at 70%, 65%, and I don't know how to do. It goes to an evaporator doesn't operate every day, what to do, right? That's a solution which we are bringing on the table. To our credentials, okay, why you should trust us. This is the reason why you should trust us. The first zero liquid discharge on the earth, okay, was done by us, okay? And these are the industry which were the first ZLD on earth was installed by us, okay? So we are not, and it's not that we have been successful every time. We have been also failed. And there's no shy in saying that we have failed. We have also failed, right? But we have always urged to learn from it, okay? And that's why today we are here saying that we have the largest installation in the world for zero liquid discharges, okay? You say power, synthetic fuels, primary, metals, microelectronics, chemicals, pulp and paper, coal mining, battery manufacturing. Actually, we did in first plant in US, which was 22 years back. PVC manufacturing, coal to chemicals. Today we have started talking about coal methanation, right? Uranium mining, petroleum and petrochemicals, oil refining, SHD. And now we have installations in India. We have around 22 installations in India, including chemicals. First installation was with Lanxess, Nagda, okay, which was around 10 or 11 years old now and still operating as designed with no drop in efficiencies, right? Some of the photographs, the 70s and 80s plants are still operating, fully meeting the compliances. So you don't have to Keep investing every day. You invest a day and you just shut it. You just forget it. Now, why these ZLDs are not operating well today? It's also another problem statement that corrosion and scaling, two are the biggest challenge we have, right? The water which goes to these crystallizers are the most, I would say, worst water we have, right? Everyone will agree that the water which is being rejected by ROs or having high CODs, which is not breakable, what to do with that water, right? You will also agree that biological process, I'm not touching right now biological process, but biological process cannot operate at high COD, right? Because they have their own limitation. The bugs will not be able to sustain themselves. Although we have done some piloting in Europe, and now we say at 40,000 COD, we can operate biological process, reducing your operating expenses, okay? So coming back to zero liquid discharge, the challenge is always when you reach a high TDS or high CODs, the biggest challenge is corrosion, spitting, and scaling, right? And if that happens, you will always clean them with acids and all, and acids is always deteriorate material, right? And that's where the biggest challenge always starts with knowing it, right? So what is important when you design a zero liquid discharge plants? Please do a very detailed chemistry analysis, very detailed, okay? Don't get into these 3-4 parameters and ask vendor to go and design my plant. It won't work. Get into 36, 40 parameters, get detailed for multiple samples. First very important component is know your water yourself. Then only you can design a plant, okay? Tomorrow else vendor will come and say, I was not aware that your calcium is so high. You never told me like that, right? So people should be aware about what I'm designing for it, okay? And wastewater chemistries are very typical. I can tell you, they can create a salt at high temperature and these ZLDs will become defunct. They will scale, and those scales are, you can't remove those scales. There are some chemistries which can be created in, you can't recover those components. You have to replace those components as well, right? So material of construction, very important. I can tell you today people talk about, look, I was doing SS316, now I'm doing 316L, now I've started doing 316 Ti. They don't work here. Let's be honest about it, okay? They don't work. Have they been working? They would have installation like this. I can challenge around it. Look, a 10-year or 15-year-old plant with no modifications being done on wastewaters shows those plants in the country. And for me, you can make it 40 years or 20 years or 25 years. Multiple installations we can go and see. Okay, like one of the largest plant we are installing in India is for Grazin Nagda. Okay, this is going to be one of the world's largest viscose zero liquid discharge. Okay, no one has that plant, right? Studies being done, plant is implemented, commission delivered. It's operating right now. We've also failed, but we have learned, right? And that's what we said, right? We understood scale, which all scale can be formed. We understood what can create corrosion. Okay, we never thought. I'm just putting up some of the thoughts. We never thought if your magnesium has more than calcium, then titanium cannot exist. We never thought like that, right? Some of the even cases when we have this like this, we find that the high magnesium wastewater was actually pitting titanium even, right? So these are the studies being done, what to do in those waters, right? Now, these are the tubes get punctured just because magnesium is higher, okay? So now on the solution part of it, our crystallizers, depending on the flow rates, are made up of either two component or one component, okay? So when we say two components, it is evaporator and crystallizers, depending on the flow. If it is 20 meter cube per hour and above, we go with two stage, evaporator and crystallizer. When it is 20 meter cube per hour and below, we go just with crystallizers, okay? So this is basically an evaporator where we do a feed tank, we do a heat exchanger with the condensate which we recover. It's a falling film, but if you see over here, there is no steam. There are basically mechanical vapor recompressors, being used, and the entire plant will operate without steam. It will only concentrate the CODs or high TDS up to 250,000 ppm. So it will only create a slurry. It won't create salt, okay? But it will reduce the quantity by 5 times or 6 times. That's a stage one. If my flow rates are more than 20 meter cube per hour. Evaporators or brine concentrators, these are mechanical vapor recompressor, as I said, energy based. These are falling film. These are generally being used to reduce the quantity. Again, not to convert into salts. They can be seeded design and unseeded design. If your water is too scaled, which can create too many scales, right? I can use seeded system and you need to clean only once in a year. You don't have to clean some of the examples, okay? So there is a water which comes called as FGD wastewater, and FGD comes in a power plants. When you have to reduce those SOx and NOx in a power plant, right? You do a lime bath of that flue gas, and that lime bath water has a hardness of around 20,000 ppm. Now 20,000 ppm hardness you cannot reduce to evaporate. You use tons of chemicals, tons of sludge to generate, right? 20,000 ppm hardness will go directly into these evaporators, okay? And with seeded slurry at 20,000 ppm hardness, they will be cleaned once in a year, okay? This is the robustness of these plants, okay? Again, these are vapor compressions. No steams are required, not TVR. We have both TVR and MVR, but in the country, what we are realizing is that MVR is making more sense because of, I explained, the steam, the fuel of the steam is getting changed from coal to gas. Okay. Typically, systems can be 2 meter cube per hour. We are installing now the smallest one is 1 meter cube per hour in the country, and it can go as high as 300 meter cube per hour, a single unit. Okay. Typically, their power requirements are 13 to 26 kilowatt hour per meter cube. Okay, that's a total power consumption they will be using it up. Now, the crystallizer component, second component, right? Now, what you have done is you have made your TDS to 250,000. Salts would start getting generated at 4 lakh plus ppm TDS, right? Now, this crystallizer is the most robust product. They will be made up of 6% moly, titanium grade 2, no small metallurgy. These are all exotic alloys, okay? Very costly alloys, but they are robust, okay? They will take TDS of 250,000 or high CODs, and they take up to 4 lakh or 5 lakh TDS, okay? And they convert into salts, okay? Now you feed anything. See, a lot of time I hear from customer, I have a batch process. My effluent keep changing, right? You feed 1 lakh TDS, you feed 50,000 TDS, you feed 10,000, you feed 2 lakh. It will give you salt out, okay? That's the robust of these machines. They don't care about what you're feeding. They have their automation in place. They'll figure out what is the density inside system, and accordingly they will select what is the cycles they will be working on, okay? So this is forced circulation system, again pure MVR driven, no steams, they will work out whatever. So generally what we do is we find out what is the boiling point of your effluent. Based on the boiling point, we select what is the fans are required, compressor fans are required, and accordingly we install the plant. Crystallizer is basically used either after evaporator. If it is less than 20 meter cube per hour, we can directly take your RO rejects and all into crystallizers, okay? Typically, vapor compressions reduces energy consumption. So whatever vapors get produced, you suck those vapors, get into compressor and push back as a high temperature in the system. Flow rates are 0.5 meter cube per hour to 115, or now it is even 200 meter cube per hour. Energy consumption, 32 to 65 kilowatt hour per meter cube, depending on the boiling point. Is it single fan, double fan, or 3 fans are coming together? Okay, and distillate is a reusable quality distillates, right? The entire flow sheets look like this. Okay, so you have an evaporator and you have a crystallizer. If you have a larger flow, okay, so you have a feed flow system. You have a heat exchanger which will exchange heat from your condensate. You go into an evaporator which is a falling film evaporator, again on energy based, MVR based. You take the TDS from 50,000, 40,000, 1 lakh to 250,000 TDS. You reduce the quantity by 5 times. That reduced quantity goes to crystallizer. Crystallizer from 250,000, take it to 4 lakh, 5 lakh, convert into salt by using a centrifuge. Okay, no ATFTs, nothing's are required here. Okay, no cleanings every day is required. Okay, the cleaning cycles are, if it is seeded system, I can go once in a year. If it is non-seeded, we can go once in 2 months. Our all cleanings of the systems are going to be only with water, nothing, no chemicals. Okay. Now, there could be a question, why guys? Why, when scaling ions are there, what is that you guys are doing that those scaling ions are not scaling your system, right? Okay. So, you design these systems in 2 methodologies, okay? You allow material to foul, you do not allow material to foul, okay? You allow material to foul, so what happens is, your circulation rates, your heat exchanger tubes quantity will be very small. Because if your circulation rates are small, your heat transfer can be better, faster, right? So but your velocity is small and your scaling is more, right? Our all system works at very high velocity. They work at 300x of your average flow. So if your average flow is 10 meter cube per hour, my recirculation is 3000 meter cube per hour, okay? So that high velocity will not allow any scaling to happen. It will not allow. It will just keep working around it. Okay. And corrosion, we always study at what pH it is making. We can operate the ZLD at 1 pH, 2 pH. Is it ammonia present? Is it non-ammonia present? What is the COD? What is the boiling point? Ammonia, you want in condensate, you want in salt. These are all objectives. We will figure out, and then accordingly solutions are being delivered. So system approach, as I was explaining, is basically it has to be robust. We are a conservative designers, okay? We will not come to you and say, look guys, I can meet your budget, I can reduce your quantity. Look, we will try. And again, I'm not bringing a flow sheet which is designed in Europe or US. It is totally designed in India, everything being done, sourced in India. Okay, we are not working on very high standbys. Okay, but minimum what is required for, we say fit for purpose, okay, is being delivered as a solution, right? Redundancies, we avoid in crystallizers because these are costly equipment, costly machines. Okay, spare strategy we maintain. So we will advise, don't go for extra pump, but go for some of the critical spares. Okay, the makes what we take for example, for pumps, we always go only with Agar. Okay, Agar is a European company, but they are in Chennai as well. What our history says, for 20 years we have not replaced them. All our fans are coming from Pillar. Okay, our history, we don't go for anyone else. So these two things are very fixed for us. We will not replace them with any other brands. Operator training, preventive maintenance, we do digital as well. So you continue to operate your ZLDs, we will continue to maintain it. Okay, we know digitally how the plant is. We will do predictive maintenance and we'll tell you, look guys, do this act. Some vibrations are increasing, so maybe you need to change your oil or some bearings are required to change. Okay. System could be seeded, non-seeded, could be energy-based, could be steam-based, okay, could be falling film, could be forced circulation. Again, these are all objectives based on your water chemistry. So what is important is to know what is the water chemistry. We will not deliver any proposal unless we have detailed chemistry available. Any customer come and says, look guys, go and design on this. We will not do that. That's very simple. It's a philosophy we always follow. Okay, what is the heat transfer area? What is the boiling point elevation your effluent has? We do all these studies, and based on this, if you see on the right-hand side, you minimize your pre-treatment. If it's mechanical vapor, is energy efficiency, you don't require steam. Falling film, forced circulation, improve your heat transfer areas. Heat transfer, boiling point, robustness, and mechanical reliability it provides. Material, corrosion, erosion, extend and build to last. Okay, 20 years, 15 to 20. You see, in India, we decided that we are not designing for 40 years, but we say 15 to 20 years is the right time scale. So all our equipments are designed for 15 to 20 years of life scale. Okay, some of these just a salt photographs, how the salts looks like. What is the key of the metallurgy? As I was touching about metallurgy as well, right? ZLD must operate and generate salts, right? That's the objective of a ZLD. ZLD is not for just a showcase machine. I think that time has gone, where we say that I need a ZLD because pollution control board is putting a pressure. Now ZLD is required as a part of sustainability. If I'm an exporter and my customer is looking for a robust solution, I just want to put it in a right way, but it has to be efficient. I don't want to just burn my money or every day. Okay, so understanding your water chemistry, based on the water chemistry, what is the boiling point? Okay, we have our own design tools available with us, where based on your water chemistry, we actually can find out what is the boiling point, okay, based on all our experiences. What is the TDS? At what TDS are you giving me? What TDS I am raising it up to? Makes are extremely important, right? Wrongly designed ZL, please understand this point, guys. Very important, okay? If you design a wrong RO, you can change membranes, you can change pumps, right? Wrongly designed ZLD, you cannot change anything. You have to live with it, okay? You cannot divorce it even, okay? You have to live with it, okay? And this is where it is very important to go deep. See, when you are spending 2 crores, 5 crores or 10 crores in designing a ZLD, right? Go and visit at least 5 or 7 installations. Even if it is in India or if it abroad. You spend another 5 lakh rupees in your visits, but it will be worth for you guys, right? Understand from those customer challenges what they faced. I would request you to do those steps strongly with all of your vendors, at least on wastewater side of the business. We have over 750 operating references globally today and 75 years of experience. I'm not getting into left-hand side, which is more about metallurgy, but we have a scanner at our booth, which is at C51. If you scan, you can go to a landing page where you will get all these presentations. You'll get every data available over there, okay? And you can connect us as much. Okay. Some of the examples, case study is the last component of my slide. this was Lanxess. The problem statement is they are making sodium benzoate. It's very tough to segregate sodium benzoate from water, okay, and you have to crystallize because government is not allowing, and there's a river where the water will go and dispose, right? It cannot be done, right? This was in 2011 when they came to us. 2012, this plant was delivered. There were challenges when the plant was commissioned. The learn cycle went for a year. The plant was delivered in 2013 and it is operating as designed. Till 2023, I'm happy if anyone want to come and visit, not even a single component has been replaced. It is operating 24/7. Customer is operating. We are not operating. They are maintaining it up. They are cleaning it up. Everything they are doing. We are only visiting once in a year for the health checkup of the entire plant. This is second case study I was talking to you about JSW problem statement of Cocoa 1. It is one of the tough to treat effluent which has ammonia, high CODs. We did AOP with ozone. So the ozone were being used to destruct those CODs. Okay, and then the 99% of the water is being recycled back for manufacturing. Okay. Now, it's not about the smaller capacity. This is the world's largest zero liquid discharge plant. The capacity of this plant is 100 MLD. Was designed by us as well. Okay. This is for the coal seam gas which is coming out and government. The segregation has to happen. No steam can be available. Over there, it's a pure energy-based design system. Okay, with a 97% overall recovery plants. Okay. Coming back to India, this is another plant for edible oil, Bunge in Gujarat. A very small energy-based plant, 40 meter cube per day, delivered around 4 years back, operating as designed. The Kargil, Davangere, where they manufacture, the pharma-grade starch. Okay, this plant was delivered in 2015, and it is operating last 8 years. Not even a single component being repaired or replaced. It's just operating 24/7. And these companies are very, I would say, they are compliance companies, right? They will not do shortcuts. And the best part with this, Kargil Davangere is the plant is next to the horticulture land. You cannot dispose. So if there is any challenge in ETP, they have to shut manufacturing. They cannot dispose of even a liter of water outside. Okay, so you need a solution which has to operate continuously. So entire wastewater system was designed by us, from collection, from the clarifier, the biological process, physiochemical, reverse osmosis, everything, ZLDs, everything was designed by us. Okay, Lanxess, just a photographs and the salt which is coming in. This is again Birla Copper, Dahej, Gujarat, where this for the copper mining, again it's an effluent with heavy metals and CODs which is not easily breakable. The Grazim Nagda, it was a photograph which was under construction, but now it is commissioned and given. It's a world's largest viscose zero liquid discharge. Just in one photograph, that we are in the country. Okay, 1,500 employees, 4 manufacturing plants, our own R&D lab, membrane manufacturing, everything is available in the region. Okay, you have any challenge, and challenge could not be only about wastewater recycling. You can say your operating expenses are higher. You would like us to reduce your operating expenses, right? Or is there any challenge inside your process, scaling, corrosion? I don't have an answer we can solve, but we can try together. Okay. So with this, thank you very much. I'm happy to answer anything if I can. Thanks so much.
This ZLD is possible in textile processing plants?
Absolutely. But look at the textile problem statement, right? See, textile, you add salt for dye, correct? So your intent of ZLD is not to make ZLD, but to recover that salt, right?
Now, all have been discharging outside water.
So it can be, absolutely. See, textile is very easy. Bangladesh, we have delivered 29 projects on textile industry. This country's oldest recycling plant was designed by us for Trident, Budni. It is operating for more than 12 years now. Okay, so we can go and visit those plants and see those ZLDs. But then I can tell you, textile problem statement is simple. It is not very tough because textile you use either sodium chloride or you use global salt for dye.
What is the minimum cost requirement financially for setting up this ZLD plant for textiles?
Sir, depend on water chemistry. Don't want to answer it, right? It's all dependent on chemistry, right? Because I'll tell you something, okay? It's also a good question. Let's say you want to come and say, Veolia, please come and design a 500 meter cube per day ZLD for me. Okay, and I'll say, look, first share me the water quality. Why do I ask this? Because we have some membranes where I can take this water TDS to 140,000 ppm. Okay, so I may help you to reduce your ZLD size by 3 times, right? So that's why we say, let's get the entire chemistry done. And then we'll tell you what is the right solution overall, not just a ZLT. Say 22. I would say in last 20, okay, we have done 22, sir. I would say 15 has come in last 3 years only. Because you can see the shift. And I can tell you, most of the plants is being taken by companies which are looking for long-term vision. And it's not only multinationals. I can give you some of the examples. Some of the dairy plants like Milk Chemist, they says we are very progressive. I don't want my PCBs or NGTs to come in, and I want to export it. They have put it. They say I want to go with the right thing. Bunge, when they're making edible oil, okay, they say their industry is very government driven because government decide edible oil price. It's very. So this is that's all right, but compliance is very important for me. I just want to do it once. So we have done for them in Kandala, and now plant is getting commissioned in Krishnapatnam. It's a greenfield. Okay, so these are the two. And then we have done multiple for Adani Wilmar. So it is like companies are looking from compliance point of view and water recovery point of view, sir. 1 meter cube per day, 1 meter cube per hour, 24. So there is two way out. Okay, good you brought in, sir. So we have installed one energy-based ZLD in Mumbai. Okay, this is for Novartis pharma company. Okay, the effluent generation is only 9 KLD, 9 meter cube per day. So their manufacturing is going to come into phases. Okay, today 9, 3 years down the line 15, 3 years down the line 24. Now they don't want to design system 3 numbers. So they says, can I design 24 and operate at 9? Okay, you can do that. So 9 KLD system, what you do is you will operate only 10 days in a month. So if the flow rates are very small, you can have a system, smaller system, but operate 10 days in a month probably. So that philosophy we can always. But 24 KLD is the smallest one. Absolutely, sir. Absolutely, sir. It can be. And these, the mechanical vapor system, these are all also, you can downgrade them 50%. So you design for 24 KLD, they can operate at 12 KLD also. So without hampering number of hours. So they will put it like that, sir. Okay? Thank you so much. Thank you.